Okay. Hi everyone, welcome back to my YouTube channel, The Math Aficionado. Today's video is going to be a video on chapter number 7, which is graphing and functions. For the list of the chapters, you can refer to the pre-algebra course outline video. I'll put that in the cards below. Okay. So now in this chapter, which is chapter number 7, we'll be covering about the graphing and the functions. Okay. So now what all lessons are the part of this chapter? I'll list it down. So here we have 4 lessons. Okay, so the first one is linear equations in the coordinate plane. The second one is the slope of a linear equation. Third is graphing linear inequalities. And the last but not the least, which is number 4. So here solving systems of equations by graphing. Okay, so these are the 4 lessons. That's the part of this chapter number 7, which is graphing and functions. Now let's start with the first lesson, which is linear equations in the coordinate plane. Okay, so let's start with the first lesson. Now this is your lesson number 1, linear equations in the coordinate plane. Okay, so this is a lesson number 1. Now starting with the lesson number 1. Now here, if you see, we have a term called linear equation. So what is linear equation? So linear equation is basically an equation. Now you're already familiar with what is equation, so I'm not explaining that again. So now here, linear equation is an equation with 2 variables whose graph is a straight line. Okay, how do we define the graph of the linear equation? So it's a set of points in the coordinate plane that are the solutions to the equation. So the graph of the linear equation are a set of points, or it is a set of points in the coordinate plane that form the solutions of the equation. Okay, so the graph is basically given by the set of the points in the plane or the coordinate plane, which are all the solutions of the linear equation. Now let's say if all the variables represent the real numbers, one can graph the equation by plotting the points to recognize the pattern, right? And then we can connect those points so that we can form the line. So suppose if you want to graph a linear equation, so what you have to do is you need minimum 2 points. So in order to graph a linear equation, you need to have at least 2 points, because we know that the line is formed by the 2 points minimum, right? So we need minimum 2 points in order to form a line. And since we know that the graph of the linear equation is a straight line, so that's why in order to graph a linear equation we need minimum 2 points. Okay, but that doesn't mean that we can have only 2 points. We can have more than two, but minimum has to be two. Okay. Now, while choosing these points, you have to include both the positive and negative values as well as zero. So it doesn't have to be only positive or negative. Rather, you have to combine the positive and the negative values along with the zero. Clear? Okay, so what we have discussed so far is a linear equation is an equation with the two variables, right? So it's an equation with the two variables where graph is a straight line. Now the graph of the linear equation is basically the set of the points that form the solutions of the equation. And also, in order to graph the linear equation, you need minimum 2 points. It can be more than two, but minimum has to be two. And while choosing the points, while choosing the points, while choosing the points, include both positive and negative points along with zero. Clear? So this is how we define the linear equation. Now let's see an example that will make things more clear. Okay, so the first example is you have to graph the equation, or you can say the linear equation, or also you can say function y is equal to x plus 2. Now this is a linear equation or a function, whatever you want to say. Now how do we graph this function, or how do we graph this linear equation? Okay, now as I mentioned that in order to graph, you need both positive as well as negative, right? So we'll be choosing few couple of values which are the mix of positive, negative as well as zero. And these values I'm choosing for x, so we'll also find their corresponding y so that we can have an ordered pair of points or the corresponding points. Okay, so what do I mean to say is we will start off with begin by choosing a couple of values for x. For example, you can choose any random values. I'm choosing -2, -1, 0, 1 and 2. So I'm maintaining the symmetry here. And now we are going to, so these are your x values, right? So we'll be finding their corresponding y values. Why we are finding both? So that we can have the, so when we add these two, so we can have an ordered pair. By ordered pair, I mean to say x and y. Okay, so let's do that. I'm creating the table here. First is your x, then is your y, and then is your ordered pair. X, y, and then this is your ordered pair, which is your x comma y. Okay, so now what are the values that we have chosen? So we have chosen 5 values, which is -2, -1, 0, 1 and 2, right? Now their corresponding y's will be, so now we know that the equation of the y is equal to x plus 2. Y is equal to x plus 2. So now you can substitute these x values and find their corresponding y's. So when x is -2, so y will be -2 plus 2, which is 0, right? When x is -1, so it is y is equals to -1 plus 2, which is +1. When x is 0, so this is 0 plus 2, which is 2. When x is 1, so 1 plus 2, which is 3. And when x is 2, so this will be 2 plus 2, which is equal to 4. So we have got the x and the y values. So now let's write them in the ordered pair. So this is -2, 0, where x is -2 and y is 0. Then we have x as -1 and y as 1. X as 0 and y as 2. X as 1 and y as 3. X as 2 and y as 4. So these are your 5 ordered pairs, or you can say the points on the coordinate plane corresponding to this given linear equation. Okay, so now the next step is plot these points on the coordinate plane. On the coordinate plane. Okay, So now let's do that. Now when I'm plotting these points on the coordinate plane, this is my positive y, this is my x, this is negative x, and this is your negative y, right? Now let's choose. So this is 0 0, then this is 1 2 3 4 5 and 6, negative 1 negative 2 negative 4 negative 5, plus 1 2 3 4 5 6, negative 1 negative 2 negative 3 negative 4 negative 5 negative 6. Okay, so what was the first point here? Let me label these points as A, B, C, D, E. So A is negative 2 0. Negative 2 0 will be this point, right? Then we have B as negative 1 1. So negative 1 will be x being negative 1 and y being positive 1. So this is B. Okay. Then the third point, which is C, is 0 2. So 0 2 will be here. Okay. And then the D is 1 3. D is 1 3. And the final point is E, which is 2 4. So E is 2 4. Okay. So now if you see, they are getting connected with a straight line, right? So you can combine these points to get a straight line. Now this straight line is basically the equation or the graph of the linear equation that's given to us. Okay, so when we plotted those discrete points on the graph or on the plane, okay, so that was your discrete function, okay, which consists of isolated points. Okay, but when we draw the line by making use of those points and also extending the line in both the direction, so we get the opposite of discrete function, which basically becomes your continuous function. Okay, so when we connect those dots, when we connect those discrete points, so that give you a continuous function for the, or otherwise continuous function, which basically line denoting the graph of the given linear function. Clear? So this becomes your continuous function, which basically is a line denoting the graph of the given linear function. Okay, so this becomes your line. Now let's extend this to both the sides. Okay, so that is what the extension look like. I hope this is making sense. So let me summarize this. So we were given the graph, we were given the function. Now we started off by choosing a few x values, both positive, negative, and 0. Okay, I figured out the corresponding y's using the table and hence from their respective ordered pairs, which is x set of x and y. Okay, I plotted those points on the graph. So now as I plot the points, so those points were the discrete points, right, indicating a discrete function. Now when we joined those points, or when we connected those points using a line and extended that in both the directions, so that gives me a straight line graph for the given linear equation. Clear? Now here Now if you remember, when I said that in order to graph a line, in order to graph a linear equation, you need minimum 2 points. Now here you must be wondering that we have 5 points. So how come we can figure out a line or the graph using 2 points? So I'll show you that also now. Okay. So now obviously it's not possible always to have all the points or to choose a large number of points when we can actually figure out from the 2 points, right? So those 2 points generally are x-intercept and the y-intercept for the function. Okay, so those 2 points are always enough to figure out a straight line graph for the linear equation. Okay, now what are x and the y-intercept? I'll show you next. Okay, so as I mentioned, if you only want to choose 2 points to determine the straight line graph for the given linear equation, so those 2 points are the points where the graph crosses the axis. Okay, so those two are the points where the graph crosses the axis. By axis I mean to say x and the y axis. Okay, so the point where the graph crosses the x-axis is the x-intercept, and the point where it crosses the y-axis is your y-intercept. Okay, so these are the points which are known as x-intercepts and the y-intercept. Okay, one more thing that you have to notice: for the x-intercept, the y-coordinate will always be 0, and for the y-intercept, the x-coordinate will always be 0. Okay, so that is how, or that is something that you have to remember. Now coming to the representation of the same on the number on the coordinate plane. So let's say if this is your line for a random equation, I'm not referring to the one that is given to us in the problem. Okay, this is a concept that I'm explaining. So let's say if this is your graph of a random equation, random linear equation. So now here, as we know that where the graph meets the x-axis becomes your x-intercept. So this becomes your, because this is your x-axis, so this becomes your x-intercept. Okay, and where it meets the y-axis, so that becomes your y-intercept. Clear? So where it meets the x-axis, that becomes your x-intercept, and where it meets the y-axis, so that becomes your y-intercept. I hope that makes sense. Okay, so now these 2 points are enough to figure out a line that is a graph of the given equation or graph of the linear equation. Okay, this is your point of origin, which is 0 0. So now here y-intercept, you see that the x coordinate is 0. For the x-intercept, you see that the y coordinate is 0, right? So this is your y coordinate, which is 0, and here this is your x coordinate, which is 0, right? So I hope that makes sense. Clear? So let me quickly summarize. So as I mentioned that we need minimum 2 points to figure out the graph of a linear equation. So those 2 points which I'm talking about are the x and the y-intercept. So x-intercept is basically where the line meets the x-axis, and the y-intercept is where the line meets the y-axis. Clear? So these two are points which are important in order to figure out the graph of a linear equation. Okay, so if you don't want to go for multiple points or the random points to start with, the way we have solved the equation, okay, so you can always go for these 2 points and figure out the graph of the linear equation. Clear? So we will take one more example and then we'll close this lesson for the chapter number sum. Okay, so then the example that I'm going to take here is we have to figure out the values of x and draw this equation in the graph. Okay, so you have to find the values of x and draw the now the problem here is the equation that is given to us is y is equal to x minus 2. Now here we'll be solving this equation using the x and the y-intercept. Okay, now how do we find the x-intercept? So as I mentioned that x-intercept is a point where your line meets the x-axis, and I also mentioned that the y coordinate is 0 here, right? So in order to figure out the x-intercept, we'll be putting the y as 0. So this will be x0 is equal to x minus 2. 2 comes here, so x will be equal to 2. So the point becomes 2 0. Okay, so the x-intercept becomes the point which is 2 0. Similarly, for finding the y-intercept, so as I mentioned that the y-intercept is the point where the line meets the y-axis, and I also mentioned that this is the point where x becomes 0, right? So now what we are going to do is we'll be putting the x as 0 in the equation. So this becomes y is equal to 0 minus 2. So y becomes negative 2. So the point which is your y-intercept becomes 0, negative 2. Clear? Now let's draw the graph. This is your positive x-axis, this is your positive y-axis, this is your negative y-axis. This is your point of origin which is 0 0. Now the x-intercept was 2 0 and the y-intercept is 0 negative 2. So let's say if this is 1, this is 2, 3, 4. So 2 0 is your x-intercept. So okay, let me label that as A and let me label that as B. So A here is 2 0, right? Which is this point, and B here is 0 negative 2. 0 negative 2. So the line becomes like this. Okay, so this is your graph of the given linear equation which is y is equal to x minus 2. Okay, which is a straight line graph basically. I hope that makes sense. Now we have learned to figure out the graph by using both the methods where we choose the random points, and also when we figure out the graph from only 2 points, which are your x and the y-intercepts. Okay, so this was all about lesson number 1, which is linear equations in the coordinate plane. Now let's move with the next lesson, which is the slope of a linear equation, which is your lesson number 2. Okay, so what was your lesson number 2? The slope of the linear equation. So let's start with the lesson number 2. So far we have seen the graph of the linear equation. Now we are going to see the slope of the linear equation. Okay. Now how do we define the slope? Slope is basically the steepness of the hill. When we talk about the slope, so it is basically steepness of the, okay, so this is what is known as slope. Now when it comes to the graph or the linear function, I'll also write that as function. So when it comes to the steepness of the linear equation or the graph or the function, whatever you want to say, so that is exactly the same thing, but instead of hill, now this is going to be the steepness of the line. So instead of the hill, now it becomes a line. Okay, so when we talk about the steepness of the line, that is what is known as slope. How do we define the slope in terms of ratio? So it is basically the ratio of vertical change between the 2 points. Okay, which is known as rise to the horizontal change between the same 2 points, which is known as run. So ratio, so slope can be written as rise over run. What is rise here? Which is your change in y, or you can say the vertical change. And what is run? So that is change in x, which is your horizontal change as well. Okay, so this is your vertical change and this is your horizontal change. Clear? So when I talk about slope, so that's your ratio of change in y to change in x. If I have to draw that graphically, or if I have to explain that graphically, so let's say if this is your x-axis, this is your y-axis, and then there's this random straight line wherein we have 2 points, which is x1, y1, and x2, y2. Okay, so in this case, sorry, let me draw it more properly. Okay, so when I talk about the rise, which is your change in y, so that is this thing, which is, so if you see carefully, so this is your y2, right? This is your y1. So what is this? This is y2 minus y1. Similarly, this is your x1 and this is your x2, right? So what is this? This is your x2 minus x1. This is known as rise and this is what is run, or this is also known as vertical change. This is known as horizontal change. Clear? So when I have to write, or when I have to represent the slope, which is generally represented with m, so that is y2 minus y1 over x2 minus x1. Okay, so this is how I will represent my slope. What is this slope? It's the slope of the line. Clear? Let's take the example. Example here will be find the slope of the line what is the line given? So the line that is given to us is like this. Now this is passing through. Here it is 1, here it is -1. So this is -half, this is +half. Okay, then here we have 2, 2, which is a point, and here we have 3 and -2. Okay, now if you see, so what is the horizontal difference here, which is y2 minus, x2 minus x1. What is x2 here? So this is your x2, y2. This is your x1, y1. Okay, so what is x2 here? 2. What is x1 here? 3. Sorry, it is -3. Okay, because both x and y are negative. So here it is x2 minus x1. So x1 is -3. So it will be 2 minus -3. 2 minus -3, right? And what about y2 minus y1? So that will be y2, which is 2, and y1 is -2. Okay, so this becomes 2 plus 3, which is 5, and this becomes 2 plus 2, which is 4. Okay, so when I figure out the slope of this line, slope is written as y2 minus y1 over x2 minus x1. So that is 2 minus -2 over 3, sorry, 2 minus -3. So this becomes 4 over 5. Let me write the intermediate step. 2 plus 2, 2 plus 3, this is 4 over 5. Okay, why? Because now my points were, this is your x1, y1, and this was my x2, y2. On the basis of that, I figure out the sum, which is my slope of the line, and that turns out to be 4 over 5. Now if you see this slope, this is a positive value, right? We know that the 4 by 5 is greater than 0. So what does this positive slope indicate? So this positive slope indicates that the line rises above from left to right. This indicates that line rises above from left to right. We also call that as ascending line. Okay, so when the slope is positive, then the line rises above from left to right, or you can also call that as ascending line. Similarly, when slope is less than 0, so the same line falls from left to right. So when I say fall, so it is of something like this. Okay, or you can also say that as descending line. Clear? If I have to draw the graph, so let me draw it properly here. So it is going to be something like this. Okay, so this is your example of a descending line or falling line from left to right. I'll also give you the example here. Let me take this example with a proper line here. Okay, so now here let's take this point as 2, -1, point B, and the first point that we take is A, which is -2 and 3. So now here, if I have to choose my x1, y1, so my y1 here is this one, and this becomes my x2, y2. So if I have to find the slope, so that will be y2 minus y1 over x2 minus x1, right? So what is y2 here? -1. What is y1 here? -3 over x2 here is 2 and x1 here is -2. So this is -4 over +4. 2 plus 2, which is +4, which is -1. So my slope turns out to be less than 0 in this case. So that's why we have a falling line from left to right. Clear? So this is how we figure out the slope, and also on the basis of the slope sign we can figure out whether the line is ascending or descending. Clear? Now this was how you solve for the slope, but then there comes a slope intercept form. So you can always express a linear function using slope intercept form. It is very important. So we can always represent a linear function in the form of a slope intercept form, or you can say linear equation in the form of slope intercept form. What is that form? So it is written as y is equal to mx plus b. Let me write what is m here. M is your slope of the line, b is your y-intercept. We have already studied about the x and the y-intercept, so here b directly indicates your y-intercept. Okay, let me take an example. Let's say if you are given the equation or the function as y is equal to 2x plus 3. Now when I compare that with my slope intercept form, which is y is equal to mx plus b, which is y is equal to mx plus b. So when I compare that, so my m is 2 and b is 3. M is 2 and b is 3. What does that mean? That means my slope of the line is 2 and my y-intercept is b. Right? Yes. So we have the slope as 2 and the y-intercept as b. So this was your lesson number 2 of chapter number 7, wherein we talked about the slope of the linear equation. Okay. Now the next lesson that we have here is graphing of linear inequalities. Next lesson, which is your lesson number 3, is graphing of linear inequalities. Okay, so if we go to the list, so the third chapter here is graphing of linear inequalities. So this is your lesson number 3. Okay, so now when it comes to graphing of inequalities, or you can say linear inequalities, so we will have to graph the ordinary linear functions, the way that we have already studied in the previous 2 lessons. But the only difference that is going to be in between a linear equation, graphing a linear equation that we have already done, and the graphing of linear inequalities that we are going to study now. So the only difference between these two is that the solution of the inequality is not going to be a line, unlike a linear equation, but rather it is going to be the area of the coordinate plane that satisfies the inequality. So here, instead of having the line as the graph of the obviously when what we have studied so far is that the graph of the linear equation is a line, right? But in the case of linear inequality, it is not going to be a line, rather it is going to be the area of the coordinate plane that satisfies that inequality. Okay, so let me write that. So the graph of the linear equation that we have studied, it is a straight line, right? But when it comes to the graph of linear inequalities, so that is not the line, rather it is the area of the coordinate plane that satisfies the inequality. That satisfies the inequality. Now what you must be wondering, what do I mean by the area of the coordinate plane? So let me explain that now. So when we draw a linear inequality, okay, so when we draw a linear inequality, it basically divides the coordinate plane into two halves, into two halves by a boundary line, which corresponds to the function. Now this boundary line corresponds to the function. Now function, I mean to say the inequality, okay, or you can say the right side of the inequality. Now one side of the boundary line contains all the solutions of the inequality. One side of the boundary line, which is represented by the function, contains all the solutions of the inequality. Clear? So one side of the boundary line contains the solutions of the inequality. Okay. Now, obviously, we know that the inequality has greater than, less than, greater than equals to, or less than equal to. These four signs basically form an inequality, right? Now, out of these four, these form, wherein we have an equality sign as well. So these are denoted by solid boundary line. When it comes to without inequalities, they are represented by dashed boundary line. Okay, I'll give you the example and that will make it more clear. Now let's take the example of y less than equal to 2x minus 4. Now this is given as your linear inequality. Now in the equation that we have studied, linear equation, we had equality sign, but here we have less than equals to, right? Now the graph obviously will be figured out in the same way, the way we figured out for the linear equation, wherein we had the x and the y-intercept. So in the similar fashion, we can figure out the graph. I'm not going into the details of how did I figure out this graph, because it's obvious. You can easily figure out from the x and the y-intercept. Now the only thing that changes here is, so this becomes my x and the y-intercept, okay, a, b. Now only thing that here we have to focus is, in the case of linear equation we had a straight line, right? But here instead of straight line, the area is going to denote the graph, right? Area of the coordinate plane which satisfies the inequality. Now the inequality here is y is less than equal to 2x minus 4. What does that mean? That means all the y's which are less than or equal to 2x minus 4. Correct? Now, how do I decide whether less than is this area or this area? Because we know that there is a boundary line, so obviously there are going to be only two areas, either left or right. Now, how do we decide whether it's the left one or the right one? So that we can decide by choosing a random point. So I know that on the right hand side, I have one point which is, let's take z, which is 3, 0. And on the left hand side, I can take any point. Let's take that as x, which is 1, 0. Now I'll try to put these 2 points into the inequality and see which one satisfies. Okay, so we will check for both the points. Now when I substitute x, which is 1, 0, in the inequality, which is y less than equal to 2x minus 4, so here my x is this right? So let's put that. So 2 times 1 minus 4, which is 2 minus 4, and that is negative 2, right? And what is y? Y is 0. So we have left hand side as 0 and the right hand side as negative 2. So is 0 less than negative 2 or greater than negative 2? It is greater, right? So that means this is not satisfying, right? That means this is not satisfying, right? Not false, or you can say not satisfied. Similarly, we will check for the other point. Obviously this is going to satisfy because that's the only option left, but still we will solve it mathematically. So z was 3 0. Now on the left hand side I have y, which is 0. On the right hand side I have 2 times 3 minus 4, which is 6 minus 4, that is 2, right? Now I know that 0 is less than equal to 2. So this satisfies, so that means satisfies the inequality. Okay, so that means the portion that we were the area that corresponds to the graph of the given linear inequality is this portion, the right portion. Okay, so the entire right area satisfies the given linear inequality. Okay, so this is what the area which satisfies the given linear. Okay, so this is the area that's a solution to the given linear inequality. Okay, I hope that makes sense. So that was your lesson number 3, wherein we studied about how do we graph a linear inequality, right? So we figure out the graph in a similar fashion, but instead of having a straight line as the representation of the solution, in the case of linear inequality, the solution becomes the area that corresponds to the part of the coordinate plane wherein the points falling in that area satisfies the inequality. Okay, we have also studied how do we figure out which area, whether it's left or right. So we choose a random point, try to substitute in the inequality, and which one satisfies becomes the area that we are intending to find out. Now the last but not the least, which is lesson number 4, wherein we'll be covering the last lesson of this chapter, and this one is, what's your lesson number 4? So this is solving the equations of solving the system of equations by graphing, right? Solving the system of equations by graphing. Now when I talk about the system of equations, right, so obviously system of equations itself is indicating that it is not one equation, right? Rather it's a multiple equation which is forming a system, right? So when I talk about system of equation, so that means system of linear equation which contains two or more equations. So this contains two or more equations. For example, let's say if you're given two equations as y is equal to x over 2 plus 2, or let me write it in decimal form. So let's say one of the equation is y is equal to 0.5x plus 2 and another one is y is equal to x minus 2. Now here you have two equations, so that's why this forms the system of linear equations. Okay, now when it comes to the solution of such a system, so that is an ordered pair, that is solution to both the equation. So when we talk about the solution, so it's a single solution. Okay, let's represent that with xy or the point A. Okay, so now this one satisfies both the 1 and 2. So that satisfies both the equations 1 and 2. Now how do we figure out this point as a solution? Or if I have to say it in other words, so how do we solve the system of linear equations? And now we are not going to solve it mathematically. We are here learning about how do we solve the system of equations graphically. Okay, so we have to figure out the solution graphically. Okay, how do we do that? Let's see. Let's take the example and I explain that using the example. Now before moving to the example, this solution will be basically the point of intersection of these two equations. So the solution that I'm talking about is the point of intersection of both the lines. Okay, or you can say the equations 1 and 2. So it is a point of intersection. By point of intersection I mean to say where these two lines are intersecting. Okay, so that common point where they intersect becomes a point of intersection and hence also become the solution of the system of equation. Now let's take the example. So the example here would be y is equal to 2x plus 2 and y is equal to x minus 1. Now this is equation number 1, this is equation number 2, and this becomes your system of linear equations. Now you already know how do we graph a linear equation. We have already studied that in the lesson number 2, right? So by making use of the x and the y-intercept, we can easily figure out the equation or the graph of the equation, right? So let's do that. Let's use the same concept, figure out the graph for these two lines. I'm not going into much details, okay? Or I'll solve it directly from the slope-intercept form. So I know that for the first one my slope is 2 and my y-intercept is also 2. Here my slope is 1 and y-intercept is -1, right? And for this one the x-intercept would be, how do we get the x-intercept? By putting the y as 0, so x will be equal to 1. For this one the x-intercept would be from again y is equal to 0, so that will give you 2x plus 2 as 0, so x will be -1. Okay, so x-intercept becomes -1 0 and here it becomes 1 0. So you already have the y-intercept. Now you can figure out the x-intercept. So for the first line the y-intercept is 2, right? So for the first one the y-intercept is 2 and the x-intercept is -1 0, so we can take this point, so this becomes this line, right? So this is your line number 1. Now coming to the other one, which is y-intercept has been y-intercept is -1 and the x-intercept is 1. Y-intercept is -1 and x-intercept is 1, so it is this line, right? Line number 2. Obviously they are going to intersect at some point, right? Let's say if they're intersecting here, how do we figure out this point? Obviously this is your solution, right? But how do we figure out this point? So when you extend the lines, obviously they're meeting some point. You can figure out by extending the point to the x and the y axis and see which coordinates it corresponds to. So here it will correspond to -4 and here it will correspond to -3. So this will be -3 and -4. So this becomes your solution for the given system of equations, also known as the intersection point of both the lines. Okay, so this becomes your solution of the system of equation, and also this is what the intersection point is. Okay, so this is how we solve the system of equations using the graph. Okay, so here we discussed about the chapter number 7, which was graphing and functions. We talked about 4 lessons and we individually covered them in detail. So I hope everything is clear to you. Okay, in the first lesson we talked about the linear equations. Okay, what are linear equations, how do we figure out the graph, okay, and how many points do we start with in order to figure out the graph. We can have more than 2 points, or we can also figure it out from the 2 points which are basic minimum, but those 2 points are x and the y-intercept. Okay, we form the table, we form the graph. Then we came to lesson number 2, where we learned about the slope. Okay, what exactly is the slope, how do we represent that mathematically as well as graphically. Okay, we have also figured out that if the slope is positive, so that means it's ascending line, and if it is negative, so that's a descending line. Okay, in the lesson number 3 we figured out how do we graph a linear inequality. It's not linear equation, it's rather linear inequality, and we figured out that unlike the solutions in the form of a line, in the case of linear inequality it is in the form of area of the coordinate plane. Now that area can be the right portion to the line or the left portion to the line. How do we decide that? By choosing a random point and see if that point satisfies the inequality. If it satisfies, so the area belonging to that point becomes the solution of the linear inequality. In the lesson number 4 we have seen that what exactly is system of linear equations and how do we figure out the solution of the system of linear equation. So what we learned is we draw the 2 lines individually, as we already know how do we graph a linear equation, and we see where these 2 lines intersect. That intersection point becomes a solution of the system of linear equations. Okay, so that was all about chapter number 7. I hope you liked and you understood everything that I explained today. So that's all for today. If you found this helpful, please don't forget to like, share and subscribe to my channel. Your support is what motivates me in keep creating this content with love and dedication. Okay, I would love to hear your thoughts in the comment section below, and please let me know if you like this video and any suggestions that you have for me for the improvement. Okay. Thank you so much. Bye.